Hello and welcome back to Keen on Maths. So last episode we were looking at this paper 1 from May 2017. If you want to follow along at home, which I'd recommend you would, go and download it from mathsgenie.co.uk. There is a link in my last video. There's also a link in the description. And in the last video I went through how to download it and what we were looking at. So flick back if you need to look at how to download it. Last episode, we looked at the first 4 questions only. We just did the first page in quite a lot of detail. We're going to try and get 2 pages done today. So we're starting off on question 5, working out 60% of 70. And I've got 2 different methods that I'd use for working out percentages of amounts. And one is using a calculator, the other one's for a non-calculator. Now this is a paper 1, so there will not be a calculator for this one. So I'm going to show you my non-calculator method. I will also show you the calculator one, just because it's worth knowing and you will be using it for a calculator paper. So we'd start off by deciding what is 100% in this question. So 100% means the whole thing, the entire amount. So 100%, that is going to be 70. So that's this amount here. And I'm just writing it as a ratio, just to make it a bit easier to break it down and show what I'm doing using that multiplicative reasoning. So I want to get to 60%. So that's on my percent side. And I want to work out what goes just there. And that's going to be my answer for this question, what goes there. But we need to get a stepping stone in the middle. Because dividing 100 to get 60, it can be done, but it's going to be using a non-integer. So it's going to be using a decimal or a fraction, which will be quite difficult to do. It'd probably be easier to use a stepping stone of 10%. And 10% is a really, really useful stepping stone. So is 5%, so is 1%. But for this question, 10% is our best one to go for, because it is a common factor of both 100, because 100's in the 10 times table, it's 10 times 10, and 60, which is 10 times 6. So you're basically looking for a common factor there. We could go for 20%, we could go for 5%, 2%, 1%, but 10%'s really easy, because to get from 100 to 10, all you need to do is divide by 10. And dividing by 10 is nice and simple. It's just to do with changing that place value. None of the digits change, they just change where they are in the number. So 70 divided by 10, that's going to get me 7. So I've just knocked that 0 off there. So now I've got 10%, I need to find 60%, and I need to scale this up now. So it's gone up, it's increased, so I'm going to be timesing by 6, because 10 times 6 gets me 60. And I need to do the same to the other side. So when we're talking about ratios, changing ratios, or even equations as well, we need to make sure if we multiply something by something on one side, we need to multiply the other side as well. I'll just re-explain that in case that cut. I don't know if it did. Cut here. So if you multiply something on one side, you need to multiply it on the other side as well. So that's true of equations, it's true of ratios. It's a really useful mathematical skill, that idea of balancing. Now it's only for timesing or dividing. It's about that multiplicative relationship between 2 things. It's not to do with adding and subtracting. So if I added 3 to this side, that wouldn't be 103% or something. So let's say I added 3 here, it wouldn't be 103%, it is 73. I can't just add something to one side, because that changes the relationship between them. It changes the ratio. It's all to do with multiplying and dividing. So I'm going to multiply this side by 6. 7 times 6, that gets me 42. So that is going to be my answer for this question, 42. That's a 2-mark question. So if we show our working out clearly, even if we don't get 42 as our final answer, finding 10% and showing that structure of dividing by 10 then timesing by 6, that's going to get us a mark. So showing a method that's as clear as that is really useful. Don't just stick down an answer, because then if it's wrong, you're going to get no marks. Question 6, Sammy spins a 4-sided spinner. We can see the spinner here, so it's got A, B, C or B. So we've got 2 B's there. And it says on the probability scale, so this is a probability scale, marked with a cross X, the probability that the spinner will land on B. So this is a probability scale. Probability scales start at 0 and they go up to 1. All probabilities have to be somewhere on that scale. So we say it's bound by 0 and 1. Can't be bigger than 1, can't be less than 0. They can be equal to both of them. So 0 probability, if something's got a 0% chance of happening, that means it's impossible. It can't happen. So 0 is impossible. 1, which is 100%. So if something's got a 100% chance to happen, that means it's definitely going to happen. So this is certain up this side. And then right in the middle, we've got 50%, it's a 50-50. So it's like a coin flip or like this spinner, to be honest, because if we have a look at the spinner, we've got 2 B's here out of 4 possibilities. And we know it's fair, so it's got the same probability of landing on all of these. That's what fair means. Biased is the opposite of fair. So I'll write that underneath. So biased is the opposite, and biased means that it's got a higher probability of getting one thing than another. So an example is like a weighted die. So you can get die that are dice that are weighted on one side. They're used to cheat, I guess, craps and things like that. So if you roll it, it's got more chance of getting, let's say, a 6 than any other number because it's got the weight in there to kind of drag it down. So this is not a biased spinner. It's a fair spinner, which means all these possibilities have an equal chance of happening. And I've got 2 possibilities that are a B. I've got 2 B's there. So that's 2 out of 4 total options, 2 out of 4. And if I just simplify that down, it's again using that same process of multiplying and dividing top and bottom, same as what we did above with this ratio. 2 quarters, if I halve the top and I halve the bottom, that gets 1/2, a half. And we can see that on our probability scale. It's right in the middle, it's just there. So that's why we've got kind of a 50% chance of getting B if we spin that spinner. It's got a half chance. Second bit, on the probability scale, mark with a cross the probability that the spinner will land on F. And if you look at the spinner, well, F isn't an option. It's only A, B, C, and B. So it's impossible to get an F. And impossible means it's got a probability of 0. So there's 0 options that are Fs out of 4. And 0 out of 4 is just 0. It's nothing. It's impossible. Moving on to question 7. I'll read it out first. Farmer buys 2 packets of bread rolls costing £1.50 each packet. 1 bottle of ketchup costing £1.60, 3 packets of sausages. She pays with a £10 note. She gets 30p change. Farmer works out that 1 packet of sausages costs £2.30. Is she right? You must show how you get your answer. So for this question, you must show your working. So you can't just put an answer, yes or no. That will get you absolutely diddly squat. So you have to show some working out to support your answer. And this is the type of question where there's a lot of information here. So what I do with this type of question, I break it down, I pull out the information, I write it out separate so I can understand it better. Because if there's too much information in my head, I just get confused. I have to structure everything. It's a really good mathematical skill to be able to structure your information. So let's start off with the first line here. So she's bought 2 packets of bread rolls. It's £1.50 for each packet. So I'm going to write out underneath bread rolls. And there is a tendency sometimes with students to not want to write anything, just want to put numbers. And it makes sense in your own head, but this is a really good signposting to show, well, this is the bit I'm working out here. And for a show that's really important to show exactly what we're doing. And it doesn't take long to write the word bread rolls, does it? It doesn't take long at all, but it's a good way of structuring our answer. So we've got bread rolls, we've got 2 packets, so that's coming from here, 2 packets, and it's £1.50 each. So my calculation I'm going to do to work out the total cost of bread rolls is 2 times £1.50. And 2 times £1.50, if I double that, that's going to get me £3. So that's how much the bread rolls cost altogether. So I've not even looked at the rest of the information yet. I've just looked at that first line and I've worked something out with it. And it's a good way to start. If you're not sure what to do, just pick some information, see what you can work out. The pieces might start coming together, or at worst, you might get a mark for doing that bit of working out, even if you don't get any further with it. So next line, 1 bottle of ketchup costing £1.60. Well, that's only 1 bottle, so we don't need to do any multiplying there. So our ketchup is £1.60. And now I can kind of predict what I'll need to do next. If I get both the ketchup and the bread rolls together, so both of these, that's going to be £3, add the £1.60. So that's going to be £4.60. So that's kind of just seeing, well, what else could I work out here? I could work out the total cost, couldn't I? So finally, we've got the 3 packets of sausages. We don't know how much they cost. She's paid with a £10 note. So she's paid with £10 and she's got 30p change. So I want to work out how much has she actually spent there, because she hasn't spent the whole £10. She's got 30p as change. So I'll put Fahima spent, and that's going to be my £10, and I'm taking away 30p. So take away, let's say, 0.3 or 0.30. Well, that's going to be £9.70. That's how much she actually spent there altogether. Okay, we're getting closer to our answer. So if she spent this amount and £4.60 of it was on ketchup and bread rolls, so that means that all the rest of it is on sausages. So if she spent this much altogether, if I take away how much she spent on the bread rolls and the sausages, £4.60, then I can work out how much she actually spent on sausages altogether. So if we just work that out, that will be £5.10. We could do a little subtraction at the side if we need just one line of working out. So that'd be £5.10. Okay, fantastic. So we've got £5.10, and this is here. Let me just signpost this. This is total cost of sausages. Lovely. So all my sausages, all 3 packets, cost £5.10 altogether. So if I want to work out what one costs, well, this is the cost for 3 of them. So if I do 3 packets here, altogether, that's going to be £5.10. So that means that just one packet is going to have to be splitting that cost equally between the 3 different parts. So it's going to be 510 or £5.10, and it's going to be dividing it by 3. And let's work this out. So 3's into 5, that goes once with 2 left over. 3's into 21, that goes 7 times with nothing left over. So we've got nothing, 3's goes into 0 times exactly. So we've got here an answer of £1.70. So £1.70 is the cost of 1 packet. So we now know that she's not right, because actually the cost of 1 packet is £1.70, not £2.30. She's got it wrong. But we need to say that. We need to give our conclusion. I've run out of room slightly here, so I'm writing a bit bigger than I would in an actual test. So let me just shrink this and move it out of the way, and I'll write my conclusion down here. So we want to write a sentence just summarising what we found out. So we found out that Fahima is wrong because 1 packet costs £1.70, not £2.30. And that's our conclusion written out. So we've shown what our conclusion is. Our conclusion is she's wrong. And we've also given the reason for it. The reason is this is what I've worked out, and that's what she said. So she's definitely wrong. Okay, so it's really good to put those conclusions in on these you must show questions and give your opinion. Right then, let's finish off this page. So I've got 2 more questions. So question 8 is split into A and B, and it's some fraction work. So first question is about multiplying fractions, and then we've got subtraction. So multiplying fractions, it's nice and easy. It's probably the easiest operation to do with fractions. It is just multiplying the numerators. So 5 times 3 is 15. And multiplying the denominators, 8 times 4 is 32, and that's my answer. Job done. It doesn't say to do it in its simplest form, and I don't think I can simplify that anyway. So 15 32ths, if you'd say it like that, 15 over 32. Now, to understand why that is, I like to draw a bar model for it. You know, I like my bar models. So if I draw a bar model representing 3/4, and it may not be perfect, but I'll try and get it half decent. We'll do it into quarters. So I'm going to need one exactly in the middle. How's that? It's not great, is it? Let's shift it across a little bit. Looks about right. And then exactly in the middle of that. That doesn't look too bad. That's a bit off. There we go. Okay, so there's a bar model representing quarters. So 3/4 would be 3 of these boxes. 1, 2, 3/4. So all of that is 3/4. And what this question's actually asking, when you're doing a times, you could replace that with the word of. So this is actually trying to work out 5/8 of 3/4. Well, there's my 3/4, and I need to find 5/8 of that, of this shaded bit here. So if I, the other way, split this into 8ths, and I shade in 5 of them, that'll be how much it is of the total shape. So splitting into 8ths, I need to split into quarters. Let's try and do it somewhat accurate. It's not going to be perfect. So this way I'm going to draw lines splitting them into 8. So that's split it into quarters. So then I need to split all my quarters in half, and then there should be 8 boxes going down this side and 4 across the top. That one's off, adjust. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So that's my 8ths going that way, and that's my quarters going that way. So if I want to find 5/8 of this shaded bit here, well, 5/8, I'll get a different colour highlighter. Let's go for a blue. And 5 of them is going to be 5 boxes this way, isn't it? So 1, 2, 3, 4, 5. And I want to find that of the whole orange area. So that is 5/8 of the orange shape. Okay? And now we just need to work out, well, what fraction is that of the whole thing? And if we have a count, there is 1, 2, 3, 1, 2, 3, 4, 5. So this box here, the blue box, is 3 by 5. So there's 15 blue boxes. So that's where the numerator comes from, the 15. And the denominator comes from, well, how many boxes are there all together? There is 4 by 8, so 4 times 8 is 32. So hopefully that gives you some understanding of why you can just multiply the numerators and the denominators. Because you're multiplying the denominators because it's quarters and 8ths, so you've got 32 boxes altogether. And the numerators, you're multiplying because you've done 3 of those quarters and 5 of those fifths. So this box here is 3 times 5. So that's kind of a bit of understanding around it. Right, last question. We've got work out 2/3, subtract 1/4. And for a question with fractions, if you're adding or subtracting, you need to make sure they're in the same thing. So because here we've got thirds and quarters, we need to make them the same denominator. Otherwise we can't work with them. We're working with different amounts. So if we change these to equivalent fractions meaning equal fractions, and I want both the denominators to be the same. We'll just have a think. If I'm using multiplicative reasoning, like we did earlier, so I've got to multiply them both by something. What could I multiply these denominators by to get the same number here. What would that number be? So we call this number a common multiple. So a common multiple. And the lowest one you can go for here is 12, but 24 will work. In fact, anything in the 12s times table will work. So 36, 48, and so on. It will all work. But this is the lowest, so we're dealing with smaller numbers. It gets a bit easier. So what do I times 3 by to get to 12? Well, I've times that by 4. And just like we did earlier, we've got to make sure it's balanced. We've got to times that by 4 as well to get 8 there. So it's just like those ratios, it's that multiplicative reasoning kind of idea. 4's into 12, well that's times by 3. So I need to times the numerator by 3 as well, I need to keep it equal and balanced. 1 times 3 is 3. So here I've got two fractions that were equal to the starting ones. So in fact, I could rewrite this question. Instead of being 2/3 subtract 1/4, I could write 8/12 subtract 3/12. Because these are the same fractions. 8/12 is 2/3. They're the same thing. We've just expressed it in a different way. 3/12 is 1/4. They are the same thing. And then if we ever think about this, well, I've got 8/12 and I've taken away 3/12. That gets me 5/12. So a mistake a lot of people make, and I think this is because they don't understand what's going on, they'd subtract the denominators as well. So 12 take away 12 gets 0. But what sense does that make? 5 over 0? What's 5 divided by 0? It's undefined. You can't divide by 0. So it doesn't make any sense to subtract the bottoms as well, because this denominator just means we're dealing in 12ths. We've got 8 of them, then we've subtracted, we've removed 3 of them. And if we had a bar model with 8, we just take 3 of them away, and now we've got 5. So our answer for this one is 5/12. And there are other answers as well, because it doesn't say put it in its simplest form, which is 5/12. We could have, for example, 10/24, 15/36. And so on. There's an infinite amount of possible answers for this question. So in the mark scheme, you'll see it'll say 5/12 OE next to it. And OE means or equivalent. So any equivalent answer. So this is equivalent, means it's equal. This is equivalent, it's equal. So any answer that's equivalent will work. Okay, that is up to question 8. And I think it's about time to call it for this video and move on to the rest of the paper next time. Do leave a comment if you're enjoying these and if you want me to go quicker, slower, if you want me to fully explain something a bit more, or I could do a whole video, for example, just on operations around fractions, because we've not done division, we've not done addition. So if you'd like that, just leave a comment and respond to any feedback you can give. And thanks for watching. It's been good fun. Cheers.